Welcome to the Copper Mountain Mine, an open-pit copper-gold porphyry mine located near Princeton, British Columbia. This impressive mining project began construction with over 1 million hours of diligent effort and was completed within budget and on schedule. Now in full operation since the summer of 2011, the mine employs around 400 people, providing substantial economic benefits to the local community and contributing hundreds of millions of dollars to the provincial economy. The Copper Mountain Mine is owned 75% by Copper Mountain Mining Corporation and 25% by Mitsubishi Materials Corporation. The project boasts a vast copper resource, with exploration potential that promises a long production life. Over the mine's 17-year lifespan, it is expected to produce approximately 1.5 billion pounds of copper, 450,000 ounces of gold, and 4.5 million ounces of silver. With capital costs totaling $438 million, the project was made possible through a partnership with Mitsubishi, which facilitated a 75-25 debt-to-equity financing at very attractive interest rates. The mine operates a $100 million fleet of mobile mining equipment, which includes 3 hydraulic shovels, 19 haulage trucks with a capacity of 240 tons each, and the world's largest mechanical loader, the Komatsu Washington 1200. This powerful loader is capable of filling the 240-ton haul trucks, while 5 Atlas Copco rotary drills ensure efficient drilling operations. Additionally, the mine is supported by a fleet of auxiliary equipment to service the Komatsu mining fleet, and a newly built 5-bay maintenance shop ensures that the equipment remains in peak condition. Currently, the Copper Mountain Mine moves about 175,000 tons of material daily, with 35,000 tons of ore being delivered to the primary crusher each day. The ore is crushed to about 6 inches in diameter and is transported via a 1-kilometer-long overland conveyor to the coarse ore stockpile located behind the concentrator building. Inside the state-of-the-art concentrator building, all operations are controlled by an advanced electronic system, allowing operators to monitor the entire milling process from a central control room. The ore is fed into a 34-foot diameter semi-autogenous grinding (SAG) mill, powered by 2 8,500 horsepower motors. In the SAG mill, water is added, and the ore is tumbled with 5-inch steel balls, grinding it to less than 2 inches in size. The resulting product is then screened, with smaller particles being directed to 2 ball mills for further grinding, while larger pieces are sent to a pebble crusher before returning to the SAG mill. The ball mills, powered by 4,850 horsepower motors, use 3.5-inch steel balls to grind the ore to a finer consistency. The ball mill product is then pumped to cyclones, where coarse material is separated and returned for further grinding, while the finer material, now ground to the size of grains, moves to the rougher flotation circuit. Here, the copper minerals are separated from the barren rock in flotation cells, where air and small amounts of alcohol create bubbles that the copper minerals adhere to, floating to the surface. The resulting concentrate, containing about 5% copper, is further refined in a regrind mill and cleaner flotation columns, producing a final concentrate with approximately 25% copper. This thickened concentrate is then filtered to reduce moisture content to around 9%, creating a product that consists of copper minerals along with small amounts of gold and silver. Copper Mountain is projected to produce approximately 175,000 tons of concentrate annually. The final product is trucked to the port of Vancouver in 50-ton units, ready for shipment to Japan, where it will be refined into copper, gold, and silver metal. With an ongoing commitment to maximizing production and minimizing costs, alongside continuous exploration efforts, Copper Mountain Mine is poised to become a world-class copper mine, delivering significant value to all stakeholders. At CCR Refinery, copper arrives with an average purity of 98%, whether extracted or derived from recycled products. However, this copper must undergo treatment to remove precious metals and chemical compounds, which are extracted during the refining process. Through this treatment, the copper attains a purity level of 99.99%. The refining process begins with the arrival of copper in the form of anodes, large plates weighing 340 kg each. After weighing, sampling, and initial treatment, these crude copper plates are placed into tanks of electrolyte, a mixture of sulfuric acid and dissolved copper. Stainless steel sheets, known as mother blanks, are positioned between each anode in the tanks. An electric current is then applied to initiate the electro-refining process, where pure copper dissolves from the anode and deposits onto the mother blank, forming a new copper plate with maximum purity, known as a cathode. The anodes remain in the tank for 21 days, while the cathodes are removed and replaced with new mother blanks every 7 days. During this process, some impurities from the anodes settle at the bottom of the tank as mud, while others dissolve in the electrolyte solution. This electro-refining process is the core of the refinery's operations, occurring in 18,800 cells divided into 9 massive aisles. The refining cycle produces 3 main products: copper cathodes, spent anodes, and anode slime. The cathodes are sent to stripping machines, where they are washed, sampled, weighed, packaged, and labeled. Samples are analyzed in our laboratory to ensure the highest industry standards for quality. The cathodes are then shipped to customers by truck, train, or boat. Spent anodes are melted down in our shaft furnace to create new anodes, recovering their full value. CCR Refinery has specialized equipment and expertise for treating anode slime, both from in-house production and from plants worldwide. The slime undergoes several processes to create finished products ready for market. Precious metals like gold, silver, platinum, and palladium are separated and refined into high-purity ingots and powders, which are then shipped to customers. The copper produced at CCR Refinery is used in various applications, from electrical wires and pipes to high-tech and medical devices. Through innovation and specialized expertise, CCR Refinery continues to contribute to the success and growth of the company. Horn Smelter, a distinctive and long-standing Canadian copper smelter, has been a significant force in the North American copper and precious metals industry since its establishment in 1927. As the largest copper and precious metals manufacturer on the continent, Horn Smelter has consistently evolved, integrating advanced techniques and sustainable practices into its operations. Today, the company is not only recognized for producing 99.1% pure copper anodes but also for being North America's leading recycler of electronic materials. This dual focus on production and environmental responsibility underscores Horn Smelter's commitment to minimizing the environmental impact of discarded electronic products. One of the cornerstones of Horn Smelter's operations is its ability to process complex materials, a capability that has enabled the company to thrive amidst the fluctuations of global markets. This resilience is matched by the company's unwavering commitment to safety. Horn Smelter adheres to stringent safety standards, which form the foundation of continuous training for both employees and contractors. A dedicated emergency response team is on standby 24/7, and the facility's security gates ensure that all movements of personnel, visitors, and contractors are meticulously monitored. Horn Smelter processes a wide array of materials, including copper concentrate and recyclable materials containing copper and precious metals. The journey of these materials through the smelter begins with proper receipt and preparation. Annually, Over 740,000 tons of copper and precious metals bearing concentrates arrive at the smelter, primarily in powder form containing 10 to 40% copper. In addition to these concentrates, Horn Smelter also processes over 100,000 metric tons of recycled materials, which range from obsolete printed circuit boards to various copper products. By refining these materials, Horn Smelter plays a pivotal role in giving metals a new lease on life, ensuring that they continue to contribute to the production of new products. Transportation and handling of materials at Horn Smelter are carried out with utmost precision and care. The smelter's operations are equipped to handle deliveries via ocean freight, rail, or road, with all transport units being weighed on certified scales before and after unloading to ensure accurate measurement. Sampling is a critical part of the process, with techniques varying based on the type of material. A dedicated team of engineers and technicians oversees quality control through a systematic statistical approach, ensuring the integrity and reliability of the sampling process. The samples are then analyzed in the company's laboratory using modern techniques, where the exact metal value is determined to meet customer specifications. The refining process at Horn Smelter is a sophisticated, multi-stage operation that begins with the Noranda reactor, a technology developed in 1973 by the company's research and development team. In the reactor, materials are liquefied at a temperature of 1,200 degrees Celsius, allowing for the separation of sulfur and iron from the copper. The resulting molten metal is then transferred to the Noranda converter, where it is further refined to increase the copper content to 98%. This semi-refined copper undergoes additional purification in the desulfurization vessel, where the last traces of sulfur are eliminated. The copper, now 99.1% pure, is cast into anodes, which are then cooled with water. These anodes, containing valuable metals like gold, silver, platinum, and palladium, are transported to the CCR refinery in Montreal for final refining. Beyond copper, Horn Smelter also produces valuable byproducts, including sulfuric acid, which is generated from the sulfur captured during the refining process. The smelter's sulfuric acid plant exemplifies the company's commitment to sustainability, as it not only reduces sulfur dioxide emissions but also produces a high-quality product used in various industries, including pharmaceuticals, automotive, and food production. Each year, Horn Smelter produces and markets 640,000 metric tons of sulfuric acid, meeting the diverse needs of its North American customers. Health, safety, and environmental respect are at the core of Horn Smelter's operations, particularly in the sulfuric acid manufacturing process. The company offers technical support for the distribution and delivery of its products, ensuring that they reach customers safely and on time. An emergency response team is always ready to address any incidents, and preventive maintenance standards are rigorously followed to maintain the highest levels of safety and reliability. Copper, a material with a rich history of use by humankind, remains a vital part of our daily lives, from cell phones to public building roofing and electric power lines. Horn Smelter recognizes the essential role that copper plays and is dedicated to maximizing its production potential, performance, and product quality. This commitment is made possible by the exceptional dedication of the company's employees and subcontractors, who work tirelessly to develop the full potential of the smelter. They are the heart of Horn Smelter's enduring success and the driving force behind its continued innovation and growth. Producing copper rods from Millbury copper wire scrap involves a systematic process in a copper cast plant, ensuring that the final product meets high industry standards. The procedure includes key steps: melting, casting, rolling, and finishing. Melting. The production process begins with the collection and preparation of Millbury copper wire scrap, a highly sought-after material due to its high copper content, usually around 99.9% purity, and minimal impurities. The scrap is first cleaned to remove any contaminants that could affect the melting process. Once cleaned, the copper scrap is loaded into a furnace for melting. This furnace, often a shaft or rotary type, is heated to around 1085 degrees Celsius, 1985 degrees Fahrenheit, the melting point of copper. During this phase, impurities separate from the molten copper. To further purify the molten copper, fluxes, chemicals that help bind impurities, are introduced. These fluxes form a slag with the impurities, which can then be removed, leaving behind high-purity molten copper. Casting. After the copper is fully melted and purified, the molten metal is poured into a casting machine. In continuous casting, which is commonly used, the molten copper flows into a water-cooled mold. As the copper enters the mold, it begins to solidify. The continuous casting process allows the molten copper to form a long, continuous billet or bar as it exits the mold. This process is crucial because it ensures that the copper maintains a uniform structure, free from internal defects. The casting process is closely monitored to maintain optimal temperatures and solidification rates, ensuring the copper has the desired properties for subsequent processing. Rolling. The solidified copper billet is then transferred to the rolling mill. The rolling mill reduces the billet's diameter and increases its length, gradually transforming it into a copper rod. The rolling process not only shapes the copper but also enhances its mechanical properties, such as tensile strength and ductility. This is achieved by compressing the metal between a series of rollers, which align the metal's grain structure, improving its performance in various applications. The rolling process is typically done in multiple stages, starting with rough rolling, followed by intermediate and finishing rolling stages, each refining the copper rod's dimensions and properties. Finishing. Once the rolling is complete, the copper rod is coiled and subjected to rigorous quality control checks. These inspections ensure that the rod meets the required standards for purity, diameter, and mechanical properties. Any defects are identified and corrected. The finished copper rod is then packaged and prepared for distribution. These copper rods are widely used in the electrical industry, particularly for wiring and cables, due to their excellent conductivity and durability.